Okay, well, because we've done so much transformations, like with our past algebra, and then we did them some more when we got to logs and exponents, I've only chosen to do two examples with these because by the time you get the basic graph down, y'all are really comfortable with transforming. So that's why I've kind of only done one or two total with this in this lesson, but let's practice here. First thing we want to do is like what we did last time, we want to list out the transformations. So first of all, let's look inside that function. Inside the function is just anything inside these parentheses. There's nothing with the x. The only thing that's in here is a plus pi over 2. And that tells me we're going to shift left. So I'm going to make sure we do the opposite. Pi over 2. Okay? And that's the only thing inside, so that's the only thing affecting the x values. The next thing we look for is a number attached to the function on the outside. There's not, but there's a minus sign, and that's going to be the next. So we're going to reflect over the x-axis. Okay, and then last but not least, we're going to shift down 2 units. Okay, so it's up to you. If you want to describe it like shifting left pi over 2 means subtracting pi over 2 from the x values, it's up to you if you want to list that out. I just need to for sure see these 3 points right here of what exactly the transformations that are occurring. Okay, with this one we're going to be graphing the y equals sine x graph. And I'm going to use the same points that I used for my x values I did for the cosine one. And if you guys want to use these every time, you're more than welcome to. So 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. And basically what this does, if you use all these points, you're just getting your quarters. So it's like 0, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. I'm just hitting all the quarters as I go along that first circle. That's all I'm doing. Okay, and then we're going for since I'm doing the sine function, I want the y values at each of these angles. So if I rotate at 0 degrees or 0 pi, I haven't rotated anything, so my y value is 0 there. If I rotate up to pi over 4, my y value there is the square root of 2 over 2, which is about 0.7. The y value at pi over 2 is 1. The y value at 3 pi over 4 is positive, so it's 0.7 because we're up in quadrant 2. At pi we're at 0. 5 pi over 4 we're negative 0.7, then negative 1, and negative 0.7, and 0. Okay, so y'all make sure you get comfortable with that. Okay, and then from here, let's start incorporating some of our transformations. We want to go left pi over 2, so I'm going to subtract pi over 2 from all those x values. We want to reflect over the x-axis, so I'm going to put a minus right there telling me to switch all those signs. Alright, so the easiest thing obviously is going to be the y one. That's not too bad at all. We got to get some practice here. So let me go through and do those. So 0, switching the signs. Can't switch sign on 0, so don't worry about that. Just going through this right side here and just swapping all the signs around. That's all I'm doing. Okay, so now let's focus on the left, on the x values. If I'm at 0 and I want to subtract a pi over 2, then it's just going to be a negative pi over 2. If I'm at pi over 4, so 1/4, if you want to take away the pi's, just focus on the coefficients. So what's 1/4 minus 1/2? Okay, well that's 1/4 minus 2/4, which looks like a negative 1/4, so negative pi over 4. If I'm at pi over 2 and I subtract pi over 2, I'm at 0. 3 pi over 4, so what is 3/4 minus 1/2? Well, that is 3/4 minus 2/4, which is 1/4. Okay, kind of make sure we match these up. At 1 pi minus 1/2 will be at 1/2 pi. At 5/4, so let's change one of these. If I change that away to 5, so 5 minus 2 is 3 pi over 4. At 3/2 minus 1/2 is 2/2, so we'll be at pi. And then 7 pi over 4 minus 1/2 So change that now to 7, and you'll be at 5 pi over 4. And then 2 pi minus a half would be 3/2, or 1.5 pi. Okay? Okay, so far in our transformations, we've taken care of shifting left, we've reflected over the x-axis, and now all we have to do is go down 2, so I'm going to subtract 2 from all those y values, and we can call this ready to graph. My x values are planted. I'm happy with those x values. I want to leave those the way they are. Nothing else is transforming with those. So negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, and 3 pi over 2. Okay, and last but not least, subtract 2. So minus 2, 0 minus 2 is a negative 2. Negative 2 minus a negative 0.7 is a negative 2.7. And then a negative 3, a negative 2.7, a negative 2. A negative 2 plus 0.7 will be negative 1.3. And negative 1, negative 1.3, and a negative 2. So we're going to use this last final chi chart right here to actually use to graph our equation. And starting out by drawing the x and y axis, looks like my x values go from a negative pi over 2 to a 3 pi over 2. And my y values are primarily in the negatives. So let's make this kind of low. Let's see, if we call this pi, we'll call that negative pi. So there's a pi over 2 and a pi over 2 there. So half, 1, half, we'll make that 2 pi. Make this 1. So there's 1, negative 1, and negative 2. Okay. So at negative 1/2 pi, we're down at negative 2. At negative 1/4, we're at negative 2.7. So we're going to go a little bit lower. We'll make that negative 3. Negative 2.7, right about there. At 0, we're at negative 3. At pi over 4, so if that's pi over 2, pi over 4 is 1/4 of the way. We're at negative 2.7. At pi over 2, we're at negative 2. At 3 pi over 4, we're at negative 1.3. At pi, we're at negative 1. 5 pi over 4, we're at negative 1.3. And 3 pi over 2, we're at negative 2. This is a good sign. I'm getting a curve. I'm always happy when I get my curve. That means I probably did all the math right. Okay, and if we can continue this pattern, at 0 we're at negative 2, so I bet you at 2 pi we're down at negative 3. We can test that if we had to, though. And it would eventually come back up over here and kind of go that direction, so y'all can see the curve throughout that. And there's a graph of the sine graph that has been transformed by shifting it right, then reflecting it over the x-axis, and then shifting it down 2.